partial sums.
9.8.
Oops, sorry. 9.2.
Going back to time machine.
Yeah, that's from an older book. They changed it. Got used to 8. Partial sums and infinite series. Alrighty. All right, so basically when they say series, right, all that really means is a summation. So, for example, infinite series, all that really means is something like this. So a sum from n equals 1 to infinity. So I'm going to sum up the terms of a sub n, a sequence. So this is the sequence that we talked about last time, but now we're summing the terms instead of listing them. So this means you add the first one, the second one, all the way till the nth term, right? And then you keep on going to infinity. Okay. Now partial sums, all that really means is the first partial sum would be just the first one. The second partial sum would be the first two. The third, of course, would be the first three. All the way till the nth term, which would be adding n of these. So all of these here are partial sums. Okay, so just so we have a quick example of what they mean, right? So let's get into the definitions here. If a sequence, or if the sequence, of partial sums, which we'll call S sub n, equal to some sum from 1 to n. Let's say k equals 1 to n of some a sub k. So if the sequence of partial sums S sub n converges to some number S, then we say that the series of the sum k equal to 1 to infinity of a sub k converges to S. And we write it this way. Okay. So the sum k equal to 1 to infinity of a sub k is equal to the limit as n approaches infinity of the sum k equals to 1 to n of a sub k, which is equal to the limit of the partial sums which would equal to S. Okay. So in this case, we call S the sum of the series. Alternatively, if the sequence of partial sums S of n equal to 1 to infinity diverges, that is to say, the limit of S of n does not exist. Then we say that the series diverges. Okay. Let me give you an example as to what the heck that means. Okay, a good example here. Let's say we have this series right here. N equals 1 to infinity of 1 over 2 to the n. We know that would be 1/2 plus 1/4, right? Plus 1/8 plus 1/16 forever, right? Now, you could technically rewrite this. Excuse me. Hold on a second. Yeah, I think we need to write a few partial sums in order to see it. So S1 we know is 1/2. S2 we know is 1/2 plus 1/4, right, which is 3/4. S3 would be 1/2 plus 1/4 plus 1/8, which is 7/8, right? Do you see a pattern?
Is it simply that like the denominator is just being multiplied like squared? Or is
That's part of the pattern. What else do you see?
Oh, of course it is, because look at the original equation.
Yeah, so that is apparent, but what about the top, the numerator? Do you see a pattern there? Can you create a general S sub n to to encompass this pattern. So you got the first part. There should be a 2n down here, right?
Yes.
Okay. If you compare the top to the bottom on each one, what is the difference?
Just
They're
one?
odd.
Yeah, it's one less, right?
Yeah.
So you could write 2 to the n minus 1. Do you agree?
Yes.
So this is the general partial sum. So this is the first 4 sums. This is the nth sum. You see what I'm saying? So now we can use this formula up here, or this theorem, or definition rather, up here, and find out, what is this limit? Does it converge? Because if the sum, because it says right here, right? If the sequence of partial sums converges, then we say that the series converges to that number. So if we check to see what this converges to, then we're good, right? If it converges, then that means the series did also. That's what we're trying to show based off this definition. But you had to figure this out yourself, this pattern. So, and you're going to see in these homeworks that you have to start figuring out what is the pattern. That way you can start using your sequence ideas or series ideas, depending on the question. So if we take the limit, I think I might be out of space. Let me start over here. If you take the limit from n to infinity of s sub n, which would be the limit of 2n minus 1 over 2n, right? Now, if I divide, like you guys, one of you mentioned last time, right? If we can divide everything by that largest term to show what the limit will be, to help us find it. So 2n over 2n minus 1 over 2n over 2n over 2n, right? That would give us the limit of 1 minus 1 over 2n over 1. What is this limit? Do you see what will happen to the 1 over 2n? Right? If you take the limit, this is 0, correct? Leaving you with 1. So the limit is 1.
And why we make this 0? I understand until this point. But why
What?
we make 1 over 2 power n is 0? Why we convert it to 0?
Because when n goes to infinity, this gets really small, right? But these don't change.
Oh, yeah. So it's tend to be 0, yes.
So it would be like this, I guess.
Right. Got it. No, got it. I got it. Thank you.
So now you use the definition. Since the limit of the partial sums is equal to 1, then the series of a sub n, which is the original was 1 over 2n, right? Converges to 1. So we're using the definition to show that it converged.
So I guess I'm just a little bit confused
Mhm.
as how you got from the second limit formula from the partial sums.
Here,
The one before that.
the previous page.
Nope. This one, but the second
Oh, okay.
thingy. This is the one we
Okay.
made, right?
Yes, it's the one we made right here.
Okay. And then,
Which
so how
we-
did we get to the next one then?
So the idea when we're taking limits, when the degrees of top and bottom are the same, you can divide every term by that value or that power. But since this is more of a power function, you can still do it. It's just a little bit different. So you divide the first one by 2 over n, the next one by 2 over n, and then the bottom by 2 over n, which gets us to here. These turn into 1, right? So then we finally take the limit, which makes this go to 0.
Thank you.
And then the whole goal is to find out if the sequence of partial sums converges to a number. And if it does, the definition says the series will also converge to that number. All right, let's talk about a different kind of series. So that's the first. So in this chapter, you're going to have a lot of different techniques to check for convergence or divergence. That's the first one. Now let's do another one. This is the theorem. So for a not equal to 0, the geometric series from n equals to 0 to infinity of a times r to the k converges to a over 1 minus r if the absolute value of r is less than 1. And diverges if the absolute value of r is greater than or equal to 1. Here, r is referred to as the ratio. One moment. Okay. So let me show you an example. So this is for geometric series. So whenever you see a geometric type, you're going to use this to prove and show that it converges. Okay. So the series of n equals 0 to infinity of, I guess 3, it's fine. 3 over 2n. this is going to be a geometric type. You just need to figure out what the heck is the R and what is your A. Okay. So what we can do, kind of set up the question a little bit, do some algebra. Technically, I can factor a 3 out, right? This would be 1 over 2n. And once that 3 is out of the way, I could say this is 3 times 1 over 2 to the n, because the n doesn't have any effect on the 1. So we can rewrite it this way. Now it is obvious, right? What is R and what is A? A is the number in front, the constant. R is the ratio, which is a half. So since R is less than the absolute value of, sorry, let me rephrase that. Since absolute value of R is less than 1, right? Then the series converges to this sum here. Six. Series converges to 6. So you see how we're just trying to show that the series converges, and then since it's geometric, you can find the sum. Now, you can't always find the sum in some of these questions. It's not when I say it's impossible, but it's very difficult. So most of the time, you're just going to say it converges or diverges, and that's it. And you're going to show why. But if it's geometric, then you can do the sum. But there's certain questions that people work on for years and they never figure out the sum, even though we know it converges. So I'm not going to force you to find a sum that no one's done before, okay? As fun as that would be. Any questions on the geometric example? No, let's do another geometric. You can tell right away what A is, right? What is A and what is R?
I think A would be 3/2, or would it?
I think A would be 1 and R would be 3/2.
Okay.
Yeah, R is 3/2. That's right. So there's no number we can pull out, right? And there's nothing in front. So yeah, A is 1. So right away, the question is this less than 1?
Oh,
No, right? So this geometric series is going to diverge. If it diverges, then there is no sum because it's infinite. So you cannot sum up infinite terms. So you will not find a sum. So since this is a geometric series, and R is greater than 1, then the series diverges. Do you see how you're going to answer these questions? Because the homework might be easy. They might just say A or B, right? Converge or diverge or something, which is not going to help you. You need to make sure when you do the homework, you write down why and what did you use to show that it diverged or converged. Any questions on 2 and 3? I'm going to go on to the next test. So that's the second test so far. So you have the partial sum definition and you have the geometric series test. So I'm going to put a star on all the tests because I recommend you put all of these tests on a formula sheet somewhere. So you need all of them for your exam. All right, let's do the next one. Next theorem is the nth term test. Also, or some people in books call it the divergent test or divergence, whatever. So if the limit of n going to infinity of a sub n is not equal to 0. So be careful with this, right? If the limit of the sequence of a sub n is not 0, then the series of that sequence, the sums of that sequence, n equals, yes, 1 is fine. Then the series diverges. So it's a powerful test, but only if this happens. If the limit is 0, then it doesn't tell you anything. So be careful. This is in logic, right? This is A implies B. B does not imply A, meaning if the limit is 0, then it converges. If it converges, that's not true. It's only one direction. Does that make sense? Don't make any other assumptions. All right, let's do an example here. The sum of n equal to 1 to infinity of 2 to the n. So your job is to look at it and say, okay, does it diverge or converge, right? That's what you're going to be doing over and over again in this chapter 9. Is checking and testing. So what you can do, you say, well, I'm not sure which test to use, but the first thing you should always do is the divergent test, the nth term test. So basically, to take the limit of the sequence is the first thing you do. So first, take the limit, right? What is the limit of this sequence?
There isn't.
Yeah, it's gonna, there's no finite limit, right? But it is gonna be infinity, right? You guys agree?
Yes.
Yes.
So since the limit, this is how you answer the question, of a sub n is not equal to 0, obviously it's not 0, right? Then the series of that same a sub n diverges, right? In other words, or that is to say, since the limit of 2 to the n is equal to infinity, then this specific series diverges. Does that make sense? Is there any questions about this? This is like that's one of the best tools you can use. It's the first tool that you use when you're doing these questions. You must always check the limit of your sequence. So this right here is from 8.9.1. That's what you were doing. So now we're going to apply it inside this theorem. Let's do another one. I'll put a note here. Each example show that the series converges or diverges. That's what we're doing. So right now you don't have any tools except geometric, partial sum, and the divergent test, or the nth term test. So when you're doing, eventually, right, I'm just gonna give you questions, and you're gonna be like, all right, figure it out. What test do you need? So that's gonna be on you. But right now we're only doing divergence, so that's what we have to do. So we're gonna take, so first step, write down what a sub n is. What is the sequence?
When what is this first symbol before the equal? N? What N?
It's a sub n.
A is N. Thank you.
Mm-hmm. One second. So basically the part that you're going to sum, it's going to be the sequence. And then you're going to have to take the limit of this and find out, is it 0? If it is 0, then we know nothing, and we need a different test. If the limit is not 0, then we know that it diverges, and we're done. Okay, but right now we don't have any other tests, so let's see what happens. So the limit of a sub n as n approaches infinity is the limit of the n factorial over 2n factorial. try to divide everything by n factorial and see if that helps me. We got the plus 1. So this will become the limit as n approaches infinity of 1 over 2 plus 1 over n factorial. When you take the limit, this will go to 0, right? This piece.
Right, like 1/2.
So yeah, the limit will be a half. What does that mean?
It converges?
This test can only tell you if it diverges. If it doesn't diverge, if this test doesn't tell you anything, if the limit is 0, so this is how I want you to think about it. If you get a limit of 0, then you know nothing. If you get a limit that is not 0, then you know that the series diverges. This is not 0, right?
So divergence.
Yeah, so since the limit of a sub n is equal to 1/2 and not 0, right? Then the series what the hell was it? 1 n factorial? Yeah, n factorial over 2 n factorial plus 1 diverges. So that's the answer. You show their diverges by using a theorem. The theorem we used was the nth term test. So it diverges by this test. So when you're doing your exam, and when you're doing your homework, I want you to write down, why does it diverge or converge, and what test did you use? There is more than one way to answer these questions. After a while, you'll notice you can use different tests and still get to the same place. But you need to make sure you understand what the definition means, what the theorem means, and how limits work. Otherwise, you won't get anywhere. So make sure you read those definitions very carefully. If you have any questions on these two examples? Sometimes the homework or a test question will not give you the sequence. They will give you a pattern, and you will need to figure out the pattern in order to do a test. So keep that in mind. All of these were given to you, right? See that? But I don't have to give this to you. I can give you a sum of numbers and ask you, does it converge or not? Does it diverge or does it converge? You see what I'm saying? For example, a quick note here. Can be written this way. You see what I mean? I could just say, hey, does this converge or diverge? I don't have to give this to you. Does that make sense what I'm saying? So you'll need to create the pattern. Sometimes the pattern is easy, sometimes it's not, and you have to think about it. And there's no easy way for me to tell you other than practice. Finding patterns is a skill unique to humans, right? You need to be able to find them. All right, the last two theorems, and I think we'll call it a day unless you have some questions. Okay. So if the series n equal 1 to infinity of a sub n converges to A, and the series from n equals 1 to infinity of B sub n converges to B, then the following is true. So the sum of both series converges to A plus or minus B. Number 2, if you multiply by a constant on your series or sequence, then it converges to C times A for any constant C. Number 3, if, I don't like the way that looks. So if one of them diverges and you add them up, then both diverge. Together they diverge. So if, let's say, this first one converges and the second one diverges, then the sum of both of them diverge. Okay. If you have any questions about the partial sum definition, the geometric series test, or the nth term test, or these three ideas here?
Nothing so far. I just feel it is probably more practice, like you said, please.
Yeah, I would recommend reading the definitions over and thinking about it. And also, you need to be very comfortable with 9.1 before you can do this one.
I can't read the first line. To what? After like converges to what? What?
Converges to A.
Professor, I'm sorry, but I want to ask you, did you get my
Mhm.
email?
Not yet. I haven't read them all yet. I'm still reading them. Let me see.
Okay. Yeah. It's regarding to the homework.
Oh, was it the one that said it closed already or something?
Yes. The 9.1, 9.8, 9.2. Both of them closed on me for the very first time in the class, but I was overwhelmed with the physics exam and calculus exam and the
yes,
project.
yes.
Yeah.
I remember now. Yes, I did get that. I'm gonna extend that. No problem.
Thank you.
How did the physics exam go?
I got 80%, so it's like very good.
That's not too bad.
B.
B. It's not too bad.
Yeah,
Is it
and
physics 2 or 1?
it's physics 1, University Physics 1 for engineering. And I'm honestly, as I told you in the email, I'm
Mhm.
very lucky with Professor William and with you, because without you explaining the material in a very good way and help us all the way that you can, I wouldn't make it through this hard time in those 2 classes until now. Like I would to drop for a long time, but because I have good instructors, I'm continuing. Honestly, you can imagine that I have a project with the state. I drive all the way to Austin and come back every day and
Oh,
work
man.
very hard over there, plus the 2 classes, plus my wife is pregnant. So it's
Yeah, that's a lot, man. That's a tough semester.
yes, very tough. Thank you.
Yeah, no problem. I mean, I want you all to do well. I mean, if the way I see it is, if you're gonna put the work in, I don't mind helping you out. If you do nothing, then I can't help you, right?
Right.
And so I try to think about it. But having Cal 2 and physics at the same time is pretty hard. I did that once and I did not like it.
Yeah, I'll not do it again.
Sometimes you have no choice. Right? All right, the homework
Right.
is open till Halloween, 9192.
Good, excellent.
And let's see here. Let's see if it's worth starting the next one or not. No, next one looks kind of hard. I think we'll wait. I need you to think about this for a while, and we'll start the next one next time. You guys have any questions from the homework or any issues so far?
One quick question, but it's not in the homework. In the number 2 here in front, because I'm writing very slow. So number 2 after the CA comma for AN or AR constant C.
There's no R's anywhere. That's gonna be N
A,
for N.
no, to the end of the line. For AN constant C, the end of this
Yeah,
line.
for any constant C.
Any, okay. Yeah.
Mm-hmm.
Yeah. Thank you.
Yeah, no problem. So yeah, if you know the series converges to A, if you put a number in front of it, it's just going to be C times that number. That's what number 2 is saying.
Yeah, done.